There was a question over molarity and molar mass, so I thought I would just make a quick video and explain how to do this problem and what the difference between molarity and molar mass is for you. So molar mass is used to change between grams and moles, or moles and grams, depending on which way you go. And we use this idea of what's called molar mass. Now, the way we calculate molar mass is by adding the masses off of the periodic table. So remember, on the periodic table, you have the number usually on top that's going to be the atomic number, the number of protons, and then the number on bottom that usually has a decimal in it, that's going to be the mass of 1 mole of that particular substance in grams. So that's the numbers that we're going to be using to find the molar mass. Now, whenever we're solving for molar mass or solving for moles, however you want to think of it, you're going to start with the given amount, either the grams or the moles, and then you're going to use the molar mass to convert. So I'll show you a problem of that on the next slide. Now, molarity is actually a unit of concentration, so we can see how dilute or concentrated a solution is. The way this one's calculated is moles of your solute, so that's where the moles came in from that previous little bit we talked about, over divided by liters of your solution. It is solution and not just solvent. Now, if you have a molarity problem, usually what's going to be, you'll have two parts of it, either the moles, the molarity, or the volume, two of those three, and then you'll rearrange the equation and solve for the third. Now, where they try to get tricky is they will give you grams and you have to go from grams to moles, or they'll want you to solve for grams. So then what you have to do is, using that molarity equation, you solve for moles and then you convert to grams. I know, people just try to be tricky. So let's do an example and see if I can clear that up, Benny. So here's one example of a problem. It says, what would be the molarity of a solution in which 0.7 moles of sodium chloride is dissolved in enough water to make 1.2 liters of solution? This one's a pretty straightforward one. So let me see if I can get my pen working here, hopefully. So on this one, we are trying to solve for molarity. I don't want that. So let's see if this one's, okay, this one's better. I have the pen now. So on this one, we're trying to solve for molarity. Molarity is defined as moles over volume, and that volume does have to be in liters. So if you're ever given it in milliliters, you have to change it to liters. Now, for this particular problem, it actually told us the number of moles of sodium chloride. So like I said, this one's pretty straightforward. So we're going to say 0.7 moles, and then we're going to divide that by the 1.2 liters. And so then you would just plug that into your calculator. I don't have my calculator right here. And so that would tell you how many moles per liter, or what the molarity is. So you could use either of the labels, moles per liter or molarity. So let's try one that's got some molar mass associated with it also. Okay, so here's another example that's a little bit more in depth. So this one says, what mass of sodium hydroxide would be needed to make a 2-liter solution of 0.1 molar sodium hydroxide? Assume that the molar mass is 39.9971 grams per mole and round to the nearest whole number. So on this one, there's two parts to it. One is looking at the idea of the solution, which is looking at the idea of molarity, and then one is changing that moles to grams. So on this one, we're going to start by looking at the idea of molarity and solving for the required part. Now for this one, you're told what the molarity is, so that's what that concentration is, and then you're told what the volume of that solution is. Now if you remember, we have this equation, molarity equals moles over volume. What we're going to do is we're going to rearrange that and solve for moles. Moles is molarity times volume, which we know we have 0.1 big M, and we have 2 liters. And remember, you always have to change that to liters just in case they try to trick you and put that into milliliters. Now I now have a calculator, so let's do some math. 0.1 times 2 will give us 0.2 moles. And now the other thing that we have to do is we have to figure out how many grams that is, because in the lab my scales won't measure in moles, my scales will measure in grams. So we have to find the molar mass. Now in this problem, they were very generous to you and they actually told you what that molar mass was. They said, hey, look, it's 39.9971. Where that comes from is the fact that you have 1 sodium. Now remember I said that you take the mass off the periodic table. For sodium, that's can round to 23.0. I like to round to 1 decimal in class. So it's actually like 22.99 something or another. There's an oxygen, which I'm going to round to 16.0. And there's 1 hydrogen, which is 1 times 1. So when I add these all together, I get 40, but that's only because I did do a little bit of rounding. Since they actually gave us the molar mass, we'll go ahead and use the one they gave to us, but that's where that number came from. Now I know that I need 0.2 moles of sodium hydroxide. Now what we're going to do is we're going to set this up like a unit conversion. Notice I put in a little times, so it's not equal. We're not cross multiplying here. What we're doing is just making one big long conversion factor type thing. Now as we do this, I want the moles to cancel, so I need to put moles on bottom. 1 mole has a mass, so what's on top and bottom are sometimes called equivalents. They have some sort of a relationship to one another. 1 mole has a mass of 39.9971 grams. Now when you go to plug this into the calculator, because these numbers are both on top, you're going to multiply them. If one of them was on bottom, then you would divide. Sometimes people get confused. This is like it's over 1, but again, this is a times. This is not an equal sign, so don't let that bother you. So I have 0.2 times 39.9971. So I get 7.99942. My units are in grams because the moles are going to cancel. And in the problem, it says, ask me to round it to the nearest whole number, which in this case would be 8. So try that, see if it helps you. If you have any other questions, let me know.